In this video, we're going to briefly discuss complex ions and why some solutions of complex ions have colors. So, complex ions refers to what happens when we put metal ions in solution. So when we dissolve copper-2 ions, for example, in solution, what we're really talking about is taking gas phase copper-2 ions and hydrating them and forming an aqueous solution of copper-2 ions. And as we've discussed previously, aqueous simply means surrounded by waters. But once that takes place, another equilibrium occurs, and that equilibrium is the equilibrium between the copper-2 ion and multiple ligands, in this case water that's in solution, and this forms the hexa-aqua copper-2 complex ion. And in fact, when we talk about copper-2 ions in solution, we are uniquely talking about this species. The question is, how do we go from a clear and colorless species, like the copper-2 gas phase ion, so that's colorless, to a solution that is pale or light blue once these waters have surrounded? And the answer lies in the 3D orbitals, which are the highest occupied atomic orbitals of the copper-2 ion. So if we look at the 3D orbitals, here we have some images of the 3D orbitals, you'll notice that they're all arranged spatially around the center nucleus of the copper ion, and not all of them are arranged or putting their electron density in the same locations. And that is going to be what causes the differences that lead to a color. So imagine in the gas phase, if we were to look at the energy level diagram, right, we have 1s and 2s and all of those atomic orbitals lower down, and then we have our 5 3D atomic orbitals corresponding to our copper-2 ion. And we know that copper-2 is D9, so we have 9 electrons in the 3D. And the next highest orbital is your 4s, and the transition that would happen with absorption of light would be between 3D and 4s, and this is not visible light. So that photon that goes between the 3D and the 4s is not going to be visible light. But this is all for my gas phase copper-2 ion. What happens when the copper-2 ion goes into an octahedral crystal field? And what an octahedral crystal field means is that the copper-2 ion is now going to be surrounded by 6 ligands all surrounding the copper-2 to make an octahedral molecule. And what you'll notice is that some of the ligands, specifically these two, which are straight up and down, and these two, which are on the x and y axis over here, they will have a greater degree of interference with some of these 3D orbitals. So these two, this is your dz squared, and this is your dx squared minus y squared. These two orbitals are going to now be overlapping with the ligands much more than the other 3 orbitals will. And what this leads to is a splitting between the 3D energy levels. So the two that overlap the most with the ligands, this is your dz squared and dx squared minus y squared, those are going to be higher in energy because there's now going to be interference between the ligands and the orbitals. The other 3 remaining, your dxz, dyz, and dxy, will be lower in energy now because there will not be as much spatial interference. And what we get is now we have a difference between here and here that can lead to an absorption of light, and this light, this photon, hc over lambda, this wavelength is in the visible region of the spectrum. Hope this has been helpful and hope this has been useful for understanding how some of these transition metal ions do have colors in solution.